Hello everyone, today we are going to be making 3D particle effects, to put it simply a 3D trail and 3D impact. Also, you may have noticed that this scene is themed for my 3D platformer series. From now on, any logic I make for that game will be presented like this. Well, now let's get started. First off, you are going to want to model your particles. You can make about 9 or 10 of them. That's because of the randomizer's limit on randomly selected numbers, but I'm going to be making 3, as that seems to be a good amount for a random shape of our particle. Now, what exactly do we want our particles to do? Well, we want a dust effect, really, that appears behind us and fades to nothing, effectively a trail. Also, for some extra flair, we can make the effect spin in place a little bit when it spawns. Doing things obviously here would end up with Dreams throwing a wrench in our fun, as in order to shrink the effect, we need to animate it with a keyframe. Unfortunately, animating size also animates position, so we have to do something to counteract this so they can shrink in place. What we need to achieve this is an invisible, non-collidable cube that holds all of our models in place, so we can use this to animate all the models proportionately, but first we are going to set up some logic because this is going to be difficult to get to later with all the models intersecting. First, pop down a microchip and open it. We're going to be needing a timer, randomizer, and a timeline. What we are going to be focusing on first, though, is the randomizer. Go ahead and open its property panel. Then we want to change the topmost slider to the amount of different models we have. This is going to allow us to randomly pick between the particle models. We just need to wire the randomizer to the power of the models. Make sure not to just use the A output, but all the ports needed. Now that we have the random logic, next we want to set up our grouping order. First, take one of the 2 cubes and group it with the models. Next, move it above the other cube and group it. This is for ease of animating, and it also anchors the particles in place. To finish up the logic, first go ahead and drag the microchip over the particle we just made, and use L1 to snap it to the model. Once you open the microchip, open the timer's properties, then use L1 plus square to set the value of the target time to 0.01 seconds. Connect the timer pulse output to the randomized input of the randomizer. This way, the randomizer is set off instantly when we spawn the effect. Next is the timeline. Using keyframes, go ahead and animate the model to shrink in place. At the end of the animation, in the timeline, place the destroyer gadget. The only thing left is to set up a rotator if we want to rotate our particle. Make it so it has 100% strength and dampening, and then adjust the speed to what you want. Now, the next part is getting the player to spawn the effect. To do this, go ahead and open up the puppet microchip and place down a new microchip. We're going to need to know how fast we're moving, so movement sensor. If we're moving a certain speed, so a calculator. An emitter to emit the effect, a timer, an AND gate, and a puppet interface. Go ahead and open up the movement sensor's properties and set it to local space. Keep it open for now, as we will need the Z motion output next. Go ahead and open up the calculator's properties panel, as we're going to use it to check if we are going above a certain speed. Plug the Z motion output into the calculator's A input. We will set it to greater than, then adjust B to about your running speed. You may need to test it with test mode in order to find out exactly how fast you are going when running. Next, open up the properties panel of the timer, and then set the timer's target time to about 0.1 seconds. Plug the pulse output into the reset input. Now plug the timer pulse output into the power of the emitter. In the emitter, go ahead and set it to emit once, time to emit 0, and recycle emits at the bottom. Set the emitted object to the effect we made, and move the gizmo right behind our player. If we were to plug the calculator into the timer now, it would work, but also if the player isn't touching the ground. In my case, I only want the trail to show up if we are touching the ground. So that's where the puppet interface comes into play. Plug the calculator's output into the AND gate, and find the puppet interface's on-ground output, and connect this to the gate as well. Next, plug the AND gate into the timer, and we will have our 3D trail. For the 3D impact, it is a pretty similar process. In fact, most of it is already done. First, copy the effect and make sure it's turned on after you copy it, or else you'll have to turn it on later. Then copy this copy into a circle and group them all. This is our new effect to be emitted. Copy our 3D trail logic, as it has most of what we need already. In the copy, go ahead and change the emitter to emit our new effect below the puppet's feet. Then, delete the timer and replace it with a counter. And also delete the movement sensor. Next, plug the distance from ground output from the puppet's interface to the calculator. And play with the B value to set the height you need to fall from to set off the effect. I used 2, as that seemed to be a good fall height. Plug the output of the calculator into the count up input of the counter. Use the output of the counter to plug into the AND gate, and use the on-ground output of the puppet interface as the AND gate's other input. Use the AND gate to reset the counter, as well as power on the emitter. Now you have a 3D impact effect. Sorry about posting this video pretty late. I have been really busy as of late and haven't had much time for dreams. I hope you all like this video. Don't forget to comment and subscribe. Now, thanks everyone for watching. Bye.